channel. If you're preparing for a coding interview, then trees are one fundamental topic you should be tackling. And in the last video of this series, we explained how to traverse a tree in a level order manner with the help of queues. However, often when asked about trees, the interviewer might be expecting a recursive approach to solve the problem, as trees are recursive by nature, as we already mentioned on several occasions. So, say the interviewer provides you with the root of two binary trees and asks you to check if these two trees are structurally identical and if the elements of their nodes have the same values or not. Now, to do that, we will have to traverse both trees, and one classic recursive binary tree traversal technique is the in-order traversal, which was discussed and implemented in multiple videos. So, to check if the given trees are the same, the first solution that may come to your mind is traversing each tree separately in an in-order manner, and then compare the results. If both lists are equal, then the trees must be structurally the same, right? Well, not exactly. If you take these two trees as an example, they will lead to the same lists, however, structurally they are different. Now, you may choose to keep this implementation and try to fix it by adding a few conditions here and there, taking into consideration null values in the lists, and maybe applying the pre-order traversal. However, you see, even if you manage to make it work, this solution is not optimal. In such questions, always try to find a way to traverse both trees at the same time, to avoid executing the same piece of logic twice. So how do we use recursion beyond what we already know, beyond the traditional traversal techniques to tackle a tree problem? Well, as any recursive problem, let's start with the sub-problem, the smallest problem at hand, and take a single node of each of the given trees as a first try. We now have two root nodes only, that's it. So our basic options are, if both root nodes provided are null, then we return true, right? If one of them is null and the other one isn't, then we return false. And finally, if none of them is null, we simply check if their values are equal and return with the result. That was the solution to the smallest subproblem at hand. Now, what if we extend this problem by adding a left and a right node on each provided root? This sub-solution, the exact same logic we just wrote, will have to be applied on each node we added. So we will have to check if both trees' left nodes are the same, and we'll have to check if both right nodes are the same, right? And only if all three conditions are met, the root nodes are the same, and the left nodes are the same, and the right nodes are the same, then we return true. This is the complete optimal solution to our problem. Notice that by writing the conditions the way we did, we are traversing the trees simultaneously in a pre-order manner. We can also traverse them in an in-order or post-order manner, but at this point the performance will not be affected, so you are free to pick the one you want. Now, after you solve this problem, the interviewer might choose to scale things up, and instead of asking you to check if both provided trees are the same, they might ask you to check if the second tree is a subtree of the first one, considering that its root can start at any node of the first tree. For example, given these two trees, the second might indeed be considered a subtree of the first. However, in the second example, the second tree provided is not a subtree of the first. Let's try to tackle this problem the same way we did the previous one, and suppose we have the most basic scenario, checking if the second tree is a subtree of the first one at the root node only and not at every single node in the tree. But wait a minute, the basic scenario brought us back to the same problem we just solved, right? The second tree will only be a subtree of the first one at the root if and only if these two trees are structurally similar. So, the solution to this problem is simply calling the method we just implemented. Okay, now if we go ahead and scale our subproblem up by taking into consideration that the subtree can begin at the left and right nodes of the root, then we will need to apply this same logic on the left and right nodes of the root, i.e. check if the second tree provided is a subtree of the first on the left node, or if it is a subtree of the first provided tree on the right node. If any of these calls return true, then we've got a solution. Also, do not forget to add corner case checks. You see, if the nodes provided are null, the recursive methods will be called, and a null pointer exception will be thrown. So our starting conditions will be the same as the ones we implemented in the previous method, meaning if both root nodes provided are null, then we return true, and if only one of them is null and the other one isn't, then we return false. The links to the LeetCode problems we solved today can be found in the description below. Let me know your thoughts and suggestions for upcoming videos in the comments section. And that's it for today. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.